Unit 8, assessment corrections number 3. A quadratic function has a vertex point of 3, 1 and passes through the point 6, negative 8. Which equation represents the quadratic equation? So we are going to have to use our vertex form, and we're going to have to figure out what our value for A coefficient is, and then we're going to need to maybe do some rearranging, because if I look at my answer choices down here, these are not vertex form, these are all standard form quadratic equations. And I know they're standard form because I don't see that parentheses squared. I also notice I can see my A, B, and C coefficients, which tells me it's standard form. So the first thing we're going to need to do is we're going to need to plug in our values for H and K, our vertex, and then that second point, we're going to have to plug in a value for X and a value for Y. That's why they're giving us two ordered pairs. Okay, remember, they are specifically using H and K so that you know that those are the numbers that refer to the location of the vertex. If they just said plug in values for X, and Y, you'd be like, well, which X goes where, which Y goes where? So that's why we're using different letters for H and K. All right, so let's start plugging in. So what we're gonna do first is we're gonna plug in for Y. So if I go up to my second point, my Y value is negative 8. So I'm going to plug in negative 8 for Y. I'm going to plug in, the next one I need to plug in is my X. So this is coming from the second point. So it's going to be 6. Okay. Now I'm going to start plugging in for H and K. So H refers to the X coordinate of the vertex. So the X coordinate of the vertex is 3. And remember, when you plug it in, it's got to be the opposite. So this is a positive 3. So I'm actually going to plug in negative 3 because remember H does the opposite. And now I'm going to plug in for Y. K is the Y coordinate of the vertex. So K is a positive 1. And remember, K goes in just like you think it should. And so now I'm going to bring down the equals. I'm going to bring down A. I have to put the parentheses squared around X and H. And now I have plugged in all of my values in that vertex form equation. So now what we're going to do is now we're going to start solving for our A coefficient because they didn't tell us what it is and we need to figure it out in order to get to our final answer, which is in standard form. All right, so what we're going to do is I'm just going to recopy this really quick. So I'm going to say negative 8 is equal to A. It's going to be 6 minus 3 plus 1. All right, now we've got to start the steps for solving A. So the first thing we're going to do is we're going to type in the parentheses squared part. So this section is going to get typed into our calculator. And so what I'm going to do is I'm going to go ahead and bring down negative 8 equals, and then I'm going to bring down plus 1. All right, so I'm going to get my calculator, and I'm going to type in this section in my calculator. I can't type in A because I don't know its value. So I'm going to do 6 minus 3, parentheses, all raised to a power of 2. And I'm going to do it that way just so that I can speed this up a little bit for order of operations. And now I'm going to press enter and make sure that all of my mental math is on track. And I got 9. So we would really look at it as A times 9, which is the same as 9A. So I'm going to write 9A here instead of A9 because that's just the proper form when you have a coefficient and a variable. You always write the coefficient first. All right, now we've got to move K. Well, what was K? K was a positive 1. I want to move K so that it can be with this Y value over here. So I need to look. I'm adding 1. So this is where your inverse operations are going to come in. So the opposite of adding 1 would be subtracting 1. So I'm going to go ahead and take away 1. And that's going to create 0, which is what we want. We want K to go to 0. And if I subtract 1 from one side, I have to subtract 1 from the other. And so now I have a negative 8 and a negative 1 that I need to combine. So you can do it two ways. You can do negative 8, and you can add a negative 1. Or you could do negative 8, and this means I am taking away 1. In both cases, I get negative 9. So I'm going to write that down. I get negative 9 is equal to 9A. And now what we're going to do is we are going to perform the math to make the coefficient of A be a 1. So right now I have a coefficient of 9, and I need to turn that 9 into a 1. Well, the only way that that's going to happen is if I either divide by 9 or I multiply by 9. And since this is multiplication, I have to use inverse operations. So I'm going to be dividing by 9. And if I divide by 9 on one side, I have to perform the same operations on both sides. So that is how this is going to turn into 1a. Well, now I'm going to check my mental math. Negative 9 divided by 9 is going to be a negative 1. So my a coefficient is a negative 1. And now I'm going to write this in vertex form. So I'm going to have y equals, and remember when you write it in vertex form, you are going to have, I'm going to write a is negative 1. You are going to see your parentheses squared. You are going to see y and x, those variables. The only variables you're not going to see are h and k. You are going to plug back in your vertex, and we're going to start with h. So remember, it's going to be plugged in as a negative 3 because I want it to have the opposite. We've got to have that sign change. And then k is going to be plugged in just like it is, so plus 1. Now, if you look at some of your answer choices down here, I know that my a coefficient, whether it's in vertex or standard form, has to be the same. So I noticed that B has an a coefficient of 1. Well, my a coefficient is not a positive 1, it's a negative 1. So I can go ahead and eliminate this because if my coefficient for a is positive, my parabola is going to open up. And because my a coefficient is negative, I know my parabola has to open down, which a, c, and d will all do. They will all open down because all the a coefficients are negative 1. So now what we're going to do is we're going to turn this into a vertex form. So the first thing we want to do is we want to take that parentheses squared part, just that x minus 3 parentheses squared part, just this piece right here, and we need to use the box method. So we need to multiply this out. So I have x minus 3 squared. Remember, power of 2 means this is being multiplied together twice. So it's really like I have x minus 3 times x minus 3. Okay, so we're going to go ahead and multiply this first. So this would be my rows. I need a row for x and negative 3. And then my second parenthesis is going to give me my columns. So I need a column for x and a column for negative 3. And now I'm going to use my box method skills to multiply this together. So I'm going to get x times x, x squared. X times negative 3 would be negative 3x. Negative 3 times x is negative 3x. And the negative 3 times itself should be positive 9 because two negatives multiplied together is positive. Positive 9. Remember, we're multiplying to fill in the boxes, and now I'm going to combine like terms. So I should end up with x squared. I have two negative 3's being combined together. So negative 3 plus another negative 3 gives me a total of negative 6x. And now I have my constant plus 9. All right, now we're going to distribute a. So remember, a is a negative 1. And instead of writing parentheses x minus 3 squared, I'm going to replace that with x squared minus 6x plus 9. And I still have the plus 1 out here, but if we're talking about order of operations, I have to multiply before I can add. So what we're going to do is we're going to distribute the a coefficient of negative 1 to all the coefficients inside the parentheses. And that's going to cause them to change. So what that's going to do is that's going to turn that into negative 1x squared. Negative 1 times negative 6 is going to make this coefficient now become a positive 6x. And then if I multiply negative 1 times a positive 9, that c coefficient, that constant, is now going to change to a negative 9. And now I have plus 1 because I got to bring that down. I can't multiply these because this plus 1 is not in the parentheses. And now we're going to combine like terms. So what we have to combine is now we've got two constants. So we've got to be able to combine those together. And we're going to get, because I'm going to use my calculator and check my mental math, I'm combining a negative 9 with a positive 1, and that's going to give me a total of negative 8. So when I combine like terms, I'm going to get an equation, f of x, because I'm using that instead of y. It's going to be equal to negative 1x squared plus 6x minus 8. And if I look at my options, I don't have a constant of 8, -8 for D, so that's out. And if I look at A and C, they look really similar. So -x squared, plus 6x minus 6x, and then -8, -8, or -8, -8. So the correct answer is answer choice A. C is not correct. Now, I want to point out that you could also use your calculator for this. Now, you would have to figure out your A coefficient, or you don't really even have to in this point. What I want to do is I'm going to use my calculator, and I know that my vertex has to be at 3, 1. So what I'm going to do is I'm going to type in my first equation, and I'm going to use my calculator's ability to find these locations on the parabola. So what I'm going to do is I'm going to hit zoom 0, and I'm going to start off here. As my first window adjustment, I may have to make further adjustments here. And I'm gonna have to, because I need this vertex to be away from the edge. So I need to cut off some of these negative y's, and I need to add more positive y's. So I'm just gonna say -50, and then 50, and I'm gonna count by 5s. I don't know. Let's see what that does. Okay, that does a little bit better. Now, I need my vertex to be at 3, 1, and I can't really see that well, so what I'm gonna do is I'm gonna use my calculator to find it. So second trace, if I wanna find any location in the coordinate plane on my graph, and since this opens downward, it's gonna be maximum 4, and now I'm just gonna move my cursor to where I think the vertex is. Now, some of you may be like, Ms. Love, that does not look like the ordered pair 3, 1, but again, I'm using my calculator to verify, because sometimes when you start just kind of estimating where things are located in the coordinate plane, it might be a little tricky. So remember, we have to lock in on the left side of the vertex. I'm gonna press enter. I'm gonna go back to where I was, and now I'm gonna lock in on the right side. And now I'm gonna press enter to guess. And I'm hoping it says 3, 1. And see, some of you, if you were going off just your eyes alone, might have missed that this has the vertex that we are looking for. So it has H and K. So I'm going to put a check because it has the vertex. Now, I also need to make sure it has point number 2, because our parabola also has to pass through this ordered pair. Well, if you're checking for ordered pairs, it is much easier to go to your table and check for ordered pairs than it is to look on the coordinate plane, because again, your eyes sometimes can be deceived. So I want to make sure it has 6, -8, and it does, so I'm going to put a double check. All right, now I'm going to go back to y equals, and we're going to do this same process for all 4 answers, because even though I got the vertex and the point number 2 I want to make sure that these other answer choices are completely wrong. And I want to make sure that I'm okay eliminating them and that I did not make a mistake here. So what I'm going to do is I'm going to clear this out, and I'm going to type in x squared minus 6x plus 10. And now I'm going to start off with zoom 0. I'm not going to hit graph because I want to make window adjustments for this parabola. Okay, and now my parabola is way down here, so I really need to see more of whatever this is, so I need to extend that down. So y min, let's do 5, and let's do, actually we're gonna do 50, and then I'm gonna do 250, and I'm gonna count by 50s. Okay, that did not help me at all. So we're gonna go back here. Oh, I need to do negative 250, that's why. I was like, why did that not? Oh, negative 250, I put them in the wrong spot. Okay, I think that should work. Oh, and now my vertex is way up here. So what I'm going to do now is I'm going to do second trace. Since my parabola is opening upward, my vertex is actually a minimum 3. So now I'm going to go here. And now I guess my vertex would be about there. I'm going to kind of guess. But I need to lock in on the left side. So I'm going to go left several times just because I'm not really sure where the vertex is, because I'm just not going to do any further window adjustments. And now I'm going to go to the right side of that several times and lock in. And now I'm going to hit guess. And it says, look at what my vertex is now. It's 3, 1. So it has the vertex I want. So now what we're going to do, does it have point number 2? And remember, if you're going to check a specific ordered pair, you're going to go to the table. 6, and it has 10, not -8. So it does not have the second order pair. Another reason why I could eliminate B using my calculator is I know that my A coefficient, if you solve for it at first, you know your A coefficient has to be negative, so you can eliminate B because the A coefficient is not negative. Now we're going to check C and D very quickly. So again, I'm going to type in my parabola, my quadratic equation. I'm going to start off with zoom 0 because I want to do window adjustments for that parabola specifically. And I'm going to need to cut off some of my negative y's. I'm going to do negative 50, and then I'm going to go up to 50, and I'm going to count by 5s. And let's see what that window adjustment does. Okay, so now, well, if I look at this, I know that 3, 1 is located in quadrant 1. Is this vertex going to be located in the correct quadrant that I need? And the answer very quickly is no. I at least know it should be, my vertex better be in the first quadrant if 3, 1 is even going to be a possibility for where my vertex is. So I'm just going to go to the table really quick. And if you look at 6, it should be negative 8, not negative 80. So this does not have both ordered pairs we need. So now I can, with 100% certainty, know that C is not the correct answer. Now I'm going to do the same thing for D. I'm going to type in negative x squared plus 6x minus 10, and I'm going to hit zoom 0. And again, I always start off with zoom 0, and then I make window adjustments from there. So I need to get this vertex away from the edge. So I'm not going to go down as far, negative 50, and then 50, count by 5s. We're going to do that and see where this vertex lands. Okay, it doesn't look like it's in the first quadrant, but I am gonna go ahead and use my calculator to check it. And because this opens down, because my A coefficient is negative, I know my vertex is a maximum, so I'm gonna press option 4. And now I'm gonna go to where I think my vertex is. That looks pretty good right there. Now I'm gonna go to the left side and lock in. I'm gonna go back to where I was, and now I'm gonna go to the right side and lock in. And now I'm gonna press enter to guess. And 3, negative 1. So it had the correct x coordinate, but it did not have the correct y coordinate, so we can say this does not have the vertex. And I also want to just make sure that it does not have point number 2, so that I feel confident knowing that D is also not the correct answer. And if I look at the ordered pair in the table, it's 6, negative 10, not 6, negative 8. So this does not have point number 2. And now I can with confidence say that I have verified this using my calculator, and I know that the answer is A.